Hello, good morning. Thanks for being here. So today I'm going to talk about like how you can use IPFS to securely serve your content. First of all, brief introduction about myself. So like I'm a research engineer at Cloudflare, which is like a web security company. Mainly I'm focusing on like distributed web project like IPFS, Ethereum, and basically how we can use these tools to like upgrade and like improve the web experience you have like on a daily basis. Also, as you like gonna see, I like croissant, and so if we meet like later on after the talk, happy to take croissant with a coffee and like whatever. Like definitely like super nice to get that. Before I get started, I just want to get like a show of hand in terms of like how many people did get a croissant while they were in Paris this week? Yeah, actually quite a lot of people. So that's a good choice. And actually like what we're going to talk about is not much different from like croissant experience like you got this week. So basically you imagine you're at a cafe, and so like what you do is usually like you're sitting and like you're asking someone like on your behalf because you're at a cafe, say, okay, like, hey, bonjour, can I have a croissant? And yeah, I mean, they come back, they have a croissant, and like, yeah, I mean, beautiful croissant. Like the crust is golden, it's like possibly hot, like just like, I mean, the great croissant experience. The thing is, I mean, that's what you imagine, and like you just said, okay, I want a croissant, but really sometimes the meaning of a croissant can really vary. In France, you will likely have this one, but sometimes you may have something that is called a croissant, but is not a croissant. And so what you really want is like, you want to be able to know that like when you're ordering a croissant, that like when you're like getting the croissant, be able to know, okay, like I'm actually getting the croissant I was asking for. And so that's one of the things in a similar way, like a way to like how you can use IPFS to like securely serve your croissant. So we're gonna talk now in like more technical details in terms of like how you can do that, but overall, that's the idea. Like you want to be able to verify and validate the thing you were asking for. So we first gonna do like a like small introduction about like how a request works for IPFS. Then I'm going to discuss naming and like the various naming method that you can have. And finally, I'm going to discuss like how you actually serve the content on the web to users and what that means for security. So first of all, IPFS. And before IPFS, you may want to know how does like a normal request in a web browser works. So usually when you make a request like on HTTP, you would like be like on your web browser, which like would be running on your local machine. This web browser, when like you will request like example.com, for instance, it needs to like do the matching from example.com to an actual IP of a server. So like you ask a DNS resolver, which gives you back an IP address. Now that you have the IP address, you can contact this IP address using HTTP, like still asking for the content of example.com. IPFS is not that different. The main difference is instead of example.com, what you will have is you will have like a content ID, which is basically the hash of the content. And so what you will do, instead of a web browser, you will have like a local node. So like you will ask that local node for the content using the IPFS protocol. And first what that node needs to do is, okay, so like you gave it like a hash, but you don't know where the hash is or like who is providing the hash. And so what you're doing is you will do like a DHT lookup to say, okay, like so like for like this BAFI hash, who is providing it? And so like you will discover that like QM1 is providing BAFI content in a similar way that like the waiter is providing the croissant. And so now that like you have discovered the peer, you will like using the IPFS protocol reach out to this peer, which is like at QM1, and the peer will return you the content, and like then it will be displayed. So in great and high level, that's how IPFS would work, and how it enables you to like then verify and validate that the content that was served by the peer is actually the one like you were hoping for, without actually knowing the peer beforehand. Now, the hash is a great medium to like actually like verify and validate cryptographically that like the content you're serving is actually the one you were expecting. However, it's not very like friendly in terms of names. And so one of the naming techniques that you can use is you can have a bookmark. So you can say, okay, like I have like this hash and like I will just like store it in my web browser and have a bookmark. it's rather easy. So like in this case, you have a resolver, which like is your web browser. So like every time you want to know, okay, this bookmark, which CID, you just go to your web browser. The web browser stores like a map of your bookmark to the CID in a local storage, and the trust anchor in this case is just your local storage. You're trusting that like the storage that you have will just not be corrupted, and that's how it works. Like very basic, simple. Then IPFS also introduced IPNS. So in a similar way that like you can discover content on the DHT, people and peers that like are participating in the DHT are also able to advertise for like their unique public key, a content that is associated to it. This content is signed with a private key, and so when you like discovering and like making the content resolution, you're able to validate that such a peer validates like is providing a specific content. IPNS has some limitation in terms of like speed, propagation, etc. And the other limitation is like you will still have like this hash because that's just how it works. So it's not human friendly, but like you already have some mutable entity. The thing you're probably the most familiar with is like DNS, and like DNS in the name is like decentralized name service, and so that's what you use like on the web. Normally, for instance, when you access example.com, you will actually like make a DNS request. And how that works is like you will use like a recursive resolver for DNS, which will like just recursively make queries to like name authorities. And these name authorities are like trusted by ICANN and like denoted like in cryptography by the DNSSEC root key. So like you have a tree of DNSSEC signatures, which go basically from like the root of DNS up into your domain. And so it's also cryptographically verified. It's like well integrated in the infrastructure today. And that definitely something like you can use to actually like serve and name your content. Finally, one other protocol I wanted to mention is ENS. So what ENS tried to provide is DNS, but on the Ethereum blockchain. And so the idea is like it follows exactly the same model with like a resolver and a registry. Usually from your browser, you will like contact like the resolver via like an RPC API or like via a local node, but the local node may not be in everyone's computer. Therefore, the like RPC API, which will like allow you to like get to the registry smart contract, and the trust anchor is like the Ethereum state. It's great because like then it's like more transparent and like a bit more trustless. However, the need to have access to the Ethereum state is also a big burden. Because it's like doesn't allow you to have like a concise proof for that state and for that name. Great. So we've seen a lot of like naming method now. So actually, how does it look like to serve your content? I'm mainly going to focus on like HTTP gateways because that's actually how most people at the moment are like accessing IPFS content. And like if you want to like have a website that is like broadly accessible today, like with the web infrastructure that we have, that's also probably what you're going to use. So there are kind of like three strategies. You can use like a pass gateway. And so basically what that will look like is you will have like the domain of the gateway, such as like Cloudflare IPFS.com, and then you will have a pass like /IPNS/example.com. And actually, it's quite good because in terms of trust, you know who you're reaching out. So like you're reaching to Cloudflare, and then you're asking Cloudflare to actually like access example.com on your behalf, which is like very good in terms of like knowing what's happening in terms of like who's serving the content, how, like the transparency is great. However, the way the web has been modeled, it always assumed that like one origin is actually controlled by one person. And so like you don't have like the same origin policy, which prevents you from like using quite a lot of like web APIs. Should be like secured local storage or like, I don't know, WebAuthn APIs or like various APIs on that. Another way, what you probably want to do is just, can I just access example.com if I have an IPFS content, if I just say example.com points to my IPFS content? And yeah, you can do that. And so like that's DNS link. And it's like quite flexible to access gateways. It's a bit less transparent to the user. Basically, the user like will access example.com. So it will not know who is serving it, but we'll know that like still be able to like validate the IPFS content associated. And also, I mean, you benefit from like, marketing standpoint. You just have example.com. You don't have like any fuzzy, complex or third-party provider involved. It just works in browser as a normal website, and so that's what most of the people or like businesses like would use. Finally, there's like a kind of like third contender, which is like the subdomain gateway. And so the idea is that instead of like accessing cloudflareipfs.com/IPNS/your domain, you will access like a subdomain of cloudflareipfs.com. And so while it's like very convenient because like then you have like the same origin policy as you had with example.com, you can access any arbitrary content, and especially like you can like access like direct access CIDs or etc. It has some kind of tricks. For instance, like you see, it's not example.com, it's like example-com, which is weird. But it's also how like the web is modeled. DNS like is like working on a recursive model, and like in order to like provide like ease of access and integration with like TLS certificate, etc. That's kind of the trick that has been adopted by the community. Another part which you need to care about when you're serving content on the web, should it be IPFS or something else, is like, of course, you will be able to validate that the content that you have is that is being served to user. The user is being able to validate that the content is actually the one they expect. However, the web is a bit more complex than that, and like when you're doing some like integration, there's a lot of like work that has been done in order to model the like sandboxing of the user, etc. And so like you will have, I think one of the things I mentioned before, like the X509 certificate, also known as SSL certificate, even though SSL is not an encryption for the web. So you will need to integrate with like an X509 certificate. So you need to have like a domain in order to get to get the traffic encrypted between like your server and the actual user. Another thing you need to care about is like the course rule, which is kind of like very constrained, especially in an IPFS model where like you know actually exactly like what content is going to be served. Most gateway will like include like the access control allow origin for like everything, meaning your website is able to access everything. You can like, and probably you should, just restrict that as you're serving the content. Finally, IPFS has immutable content, but it doesn't mean that like the content will be fined, and it doesn't mean that like sometimes, I don't know, you access example.com/something that doesn't exist. Well, it doesn't exist, so you need to be able to serve an error to the user. And so like now you have like custom for 4 pages. Finally, briefly, what does that mean in terms of like securing the content that you're serving? IPFS like has definitely evolved and like usage has grown. And so in terms of like HTTP content providing, still like in constant evolution. Names have been hard historically for the web, and like they are also hard for immutable content serving, especially if you want like to keep the same trust guarantee that you have with this immutable content storage. Finally, there are integration in browsers that are coming more and more, and this is being worked on. And yeah, that's it for me. More information on the blog if you want, and yeah, questions open.
Anyone have a question? No?
Well, thank you.